Here's a question. You have a string of characters. What's the longest chunk you can cut out where no character appears twice? Take abcabcbb. The answer is 3. But how would you find that systematically? Here's the string, abcabcbb, indexed 0 through 7. We want the longest stretch with no repeating characters, and we return its length. Positions 0, 1, 2 give us abc, all different. Length 3, that's our target. What would you try first? Fix a starting point, then scan right until you hit a character you've already seen. Start at 0, bt, then index 3 is again, stop, length 3. Now start at 1, bt, then index 4 is b, stop. Also length 3, same answer but look at the overlap. We just rechecked b and from the previous pass. Every new start means scanning characters we've already examined. On a long string that adds up fast, we need a way to avoid the repeated scan. Here's what we're throwing away. When we hit the duplicate a, we already knew the window held a t. We had that information. What if instead of restarting, we just nudged the left edge forward until the duplicate was gone? That's the sliding window. A left pointer and a right pointer. Right grows the window, left shrinks it. We need instant answers. Is this character already in the window? That's a set. Think of a guest list. Names only, no duplicates. You might think to add the character first, then check. Don't. Check first, then add, or you'd match a character against itself. The rule: while right's character is in the set, remove from the left and slide left forward. Then add right's character. Left and right both start at 0. A is not in the empty set. We add it. Window is 1 wide. Max is 1. Right moves to 1. B is not in the set. Add it. Window spans 0 to 1. Max is 2. Right to 2. C is not in the set. Add it. Window is 3 wide. Max becomes 3. Right to 3. That's again. Is already in the set. Duplicate. Remove at index 0. Slide left to 1. Is out of the set. Add the new a. Window spans 1 to 3. Right to 4. B is in the set. Remove bat left. Slide to 2. Add new b. Window is 2 to 4. Max still 3. Right to 5. C repeats. Remove at left. Slide to 3. Add say. Window 3 to 5. Max still 3. Right to 6. B is in the set. Remove at left. Slide. Is still there. Remove ab 2. Slide again. Now b is clear. Add it. Window is just 2 wide. Right finishes at 7 the same way. Max never exceeded 3. Notice what happened. Both pointers only ever moved right. Every character entered the set once and left once. No backtracking. Each character enters the window once and leaves once. The set holds only the current window. Time and memory both grow with the string's length. Okay, same logic in Python. We initialize the set, the left pointer, and the running max. The outer loop walks right one step at a time through every character. The inner while keeps removing from the left until the repeat is out of the set. Then we add the new character and check if this window beats our best. Hand back the best length we found. And that's the pattern. Grow until you can't, shrink until you can. You'll see this shape again.